So I converted already. So I changed this thing already. Okay. So we're definitely going to use the chain rule for this one, but you got to be careful because the 1/2 power isn't for the whole thing. So how do I say this? So it's not like it would be a different problem if it were like that. The 1/2 was for the entire thing. The 1/2 is just for that part there. Okay. So technically we're going to use the chain rule, but not really. Okay. What we're going to do, so really this is the inside stuff. It's natural log of all of this guy, which is right here. It's natural log of that. Okay. So let's go back to what we started with. The derivative of a natural log. The stuff on top is the derivative of the stuff. So that's where we're going to do the derivative over whatever the stuff is. Okay, so we just rewrite it on bottom. The top is where we find the derivative of whatever the natural log is. Okay. Okay, so let's go back to that problem. Okay, so we got y prime. So the bottom is just rewritten, the stuff. So the stuff in orange, it's just going to be rewritten. X squared plus 2x to the 1/2 power. Okay. The top is the derivative of that stuff. Well, to find the derivative of that, that's where I'm going to use the chain rule. Okay. So to find the derivative of the orange stuff, I'm going to move the 1/2 to the front. Rewrite the inside. Subtract 1 full power. Chain. Now I'm going to find the derivative of the inside. The parentheses. That would be 2x plus 2. Done. That's the derivative. Okay, the calculus part is done. Now what we have to do is kind of clean it up a little bit. Okay, the first thing I see, this guy right here has a negative exponent. So to make it positive, it's got to move down. And then this guy's a fraction, so I'm going to move this 2 down. The 1 will stay on top, the 2's got to go to the bottom. Or actually, you know what? I'm not going to do that because I could do that, but I'm not going to because I'll show you why. So let me do what I just said. I'm going to do. So I have 1/2, 2x plus 2 on top. On bottom, I have x squared plus 2x to the 1/2 power times x squared plus 2x to the 1/2 power. So the reason I didn't move the 2 to the front or the bottom is because I can just distribute to get rid of that. I can just distribute that 1/2. So that would just be 1x plus 1. What about the bottom? How do I simplify the bottom? Yeah, they are exactly the same base. This is the base. This is the base. So the rule is if they have the same base and they're being multiplied, we add the exponents. So 1/2 plus 1/2 makes 1 whole. So we don't need the parentheses anymore if it's 1 whole. Because it would just be to the first power. Now the bottom I can factor. The bottom is a binomial that I can factor. I can factor out an x. But when I do that, would that cancel out with anything on top? No. So it's not needed. So you don't need to do it. Only factor when it's going to lead to something important. If it's going to lead to something canceling out, then factor. If it's not, and in math 3, we factor just to practice. That's what I'm doing with my math 3 class. We're factoring. We factor just to practice factoring. In this class, we only factor when we need to factor, like when it gets us somewhere, right? So in this case, we don't need to. It does. I know it does have a GCF, but it's not going to lead us to cancel out with x plus 1. So it's done. Okay. All right. Let's look at the next one. Okay. It's a natural log problem, right? It's a natural log. So we know how to find derivative of a natural log, right? We just did it. We've been doing it pretty much this whole unit, this whole section. That's the natural log stuff. Okay. Which is right here. I just rewrote it. Okay. So the derivative of a natural log says the derivative of the stuff, the derivative of this guy is going to go on top. Whatever it is going to go on the bottom. So it's going to repeat on the bottom. So I'm just going to write it on the bottom because it's going to repeat. So x squared minus 1, x squared plus 1, 1/2 power. Always repeats on the bottom. Now the top is where I'm going to find the derivative. That's where I'm going to use the chain rule. So the first thing I got to do is move the 1/2 to the front, just like I did the last problem. So 1/2. Rewrite everything on the inside. Subtract a whole power. Chain. Now I have to find derivative of the inside of the parentheses. Now the derivative of the inside of the parentheses is a fraction. It's a division problem. So I got to use the quotient rule. Let me give myself a little bit more room here. Okay. So now I'm focused on the inside. Let me highlight that a different color. The inside. Okay. Low times the derivative of the high, which is 2x, minus the high times the derivative of the low over the low squared. That's the derivative. So calculus is done. I don't have to worry about any more calculus because that's the derivative. Problem is, we've got to clean that up. A lot of it is cleaning up. So the first thing I'm going to do is simplify this part, the second part over here. First thing I'm going to do is I'm going to simplify this guy right there. This guy can move to the bottom, right? This guy right here, it's just going to move to the bottom because that's a negative. So you can do that too. But what I'm going to do here is I'm going to distribute. And I can move that. While I'm doing that, I can move this guy to the bottom. So a lot of pieces moving. Okay. So I have 1/2 times. On the bottom, I have two big fractions. Okay, so when I distributed, I had, let's see, it would be 2x to the third power plus 2x minus 2x to the third power minus 2x. And then x squared plus 1 squared. Now I get to distribute the negative. When I distribute the negative, it's going to make this negative and this positive. So the cubes are going to go away. So that's going to leave 4x at the top. Okay. So I have 1/2 times 4x, x squared plus 1 squared. And then on the bottom, I can combine those two guys. Because again, they have the same base. So it's going to be x squared minus 1 over x squared plus 1 to the first power. Okay. Next thing I can do is I can cancel out the 2 and the 4. That becomes a 2. That becomes a 1. Because they're multiplying fractions. Okay, so I have x over x squared plus 1 squared on top. On bottom, I have x squared minus 1 over x squared plus 1. Oh, yeah, sorry, 2x, yep. 2x at the top, thank you. Yep, 2x at the top. Fraction divided by a fraction, keep, change, flip. So I'm going to keep the top one as is. Change to multiplication and flip the bottom. Mm-hmm. Yeah, so stuff will cancel out here. Let me get another piece of paper. So x squared plus 1 will cancel out with one of these x squared plus 1. So that'll become just 1x squared plus 1. So that becomes a 1. That becomes a 1. And that's about it. So you'll get 2x on top, and then you'll get x squared plus 1, x squared minus 1, which is difference of squares, but you don't need to multiply it. We only do those things if it helps us, but it's not going to help us do it. So you don't need to do those things. Done. Okay. All right. That's about as intense as they'll get. Okay. Most of the time, they don't go that far, but because that one had a fraction on top of another fraction, that's what kind of extended it. And we had to use the quotient rule. Anytime you use the quotient rule, it just kind of extends a problem. That's why I told you guys, if you can avoid the quotient rule, do it. Try to, because quotient rule tends to make problems longer and more drawn out, but we couldn't avoid it that time, so we had to do it. Okay, so let's go to the last page. Last page. So this one mixes, it's got e to a power. It's got natural log, right? It's even got an exponential. So it's got 3 terms. So this guy has 3 terms. This is the first term. That's the second term. That's the third term. So it's really 3 different problems. 3 different problems, okay? So we're just going to do each one as they come. So the first one is the blue. Okay, I'm not worried about the others yet. I'm just worried about the blue. Well, it's an exponential. How do I know that? Because the exponent is up in the sky. The exponent is up in the sky. I don't care that it says tangent of 3x. That's not my concern. My concern is, what is it? Is it a polynomial? Is it exponential? Is it a log? Is it trig? It does have trig in it, but that trig is up in the sky, and the exponent's up in the sky. So this is an exponential. Okay, it's e. So let's go back to our rules. How do we find derivative of anything with e? What's the first thing it does? Repeats itself, rewrite it. So that's the first thing we're going to do. We're going to rewrite it. And then we're going to chain on the derivative of the stuff up there, right? Okay, that's what we're going to do. Okay, so rewrite it. E to the tan 3x. Chain. So now my focus is up there. So it's tangent of 3x. Sometimes they put parentheses around the angle, sometimes they don't. How do I find derivative of tangent of 3x? You guys just did it on your homework. How do I find derivative of just this guy here? Don't I have to use the chain rule? First thing you do is find derivative of, let me use a different color, the outside, and then the inside. So the derivative of tangent is secant squared. Everything on the inside stays. Times the inside, which is 3. Done. That one's done. Plus. Now we're going to go to the green one, the next one. That guy's also an exponential. How do I know? Because the exponent's up in the sky. The x squared, the x is up in the sky. That's a regular exponential. We haven't done one like that, but we know what we can. It's the same spot. It's located in the same spot. That's an exponential. So 6 is a, x squared is u. So if we follow this, the first thing we're going to do is the natural log of a. So the natural log of 6 times, it repeats itself, right? Times the derivative of the stuff, whatever's in the sky. Okay, that's what we're going to follow along with. Okay. So, natural log of 6 times repeats itself times the derivative of the exponent, which is 2x. Done with that one. Last one. We've been doing a bunch of these. Natural log of secant. That's a natural log. So the natural log says the derivative of whatever the natural log is goes on top. On bottom is just whatever it was. So secant of x is going to go on the bottom. The derivative of secant of x is going to go on top. What's the derivative of secant of x? Secant x, tangent x. Done. Now I got to clean it up a little bit. Again, I still have three terms. I still have all three terms. They're joined together by plus signs. Here's the first term. Here's the second term. And here's the last. Oops, let me use the color. Same color I used. This is the last term. So anything we can cancel out, anything I can combine, anything I can do, simplify, that's what I want to do. So for the blue, the only thing I can see is moving the 3 to the front. So 3 to the front in front of E. So 3E tangent 3x times secant squared of 3x. That's the only thing I can see. I can't really combine anything there because there's nothing to multiply. The green. Can I multiply any of those 6 times 2s or 6s? Can I multiply any of the 6s or the 2s or anything like that? Can I multiply any of those guys, like 6 times 6 or 2 times 6 or 2 times 6? Any of those? No, yeah, I can't. So the only thing I'm going to do is I'm going to move the 2x to the front. Done. Okay. Now I'm on to the orange. Can I do anything with the orange? Yes. What can I do with the orange? Yeah, the secants are going to cancel out, become ones. They can divide each other. So that one I'll just be left with tangent of x. And you are done. So it was really, that one was just really 3 problems put into one. So we just did each of them on its own, and that's it. Okay, let's see. Okay, so now I want you to try letter K. I want you to try letter K. First thing you're going to do is find the derivative. For letter K, first thing you're going to do, find the derivative, find y prime. That's the first thing you're going to do. Your answer is going to be an equation. But the first thing you're going to do, the hardest part about this, and it's not really that hard, is finding the derivative. So that's what I want you to do. Find the derivative of, find y prime. Y prime. All right, guys, so that's the derivative. So now you have to find the slope, right? Because we have to figure out the slope. Well, first of all, we have our points, right? 4 is y, x is 1. So we got our points there. All we have to find is our slope now. So how do we find slope with the derivative? What do we always do when we're trying to find slope of the tangent line and we have a derivative? So I give you a derivative equation, and I said find the slope at 1, 4. What are we always going to do? Plug in the x value. Plug in 1 in this case. Plug in the x value. Everywhere you see an x, plug in a 1. So I get 8 times 1 minus 4 times 1 over 2 times 1 squared minus 1. So I get 8 minus 4 on top, 2 minus 1 on bottom. So I get 8 minus 4, which is 4. Done. Okay. Just like that. All right. Okay, so we have some time. I don't want to start the assignment yet because I want to give you guys a chunk of time so where you guys can ask questions and do it that way. So I want to give you a couple more practice problems and then we'll be done today. So tomorrow, all we're going to do is practice 10. So practice 10, we'll do that in class. Thursday, we'll go on to a new lesson, but tomorrow, we're going to do practice 10. Okay? All right, so let's see. Let me give you another problem. Letter L. Okay, so here we go. Find y prime for this guy. Find y prime. I'll give you 2 problems. That one, I'll give you an E problem, and I'll give you a log problem. There you go. Try those 2. Okay, so the first one's product rule. So product rule says first one times the derivative of the second. Well, the derivative of e to the negative x, the derivative of e to anything repeats itself, and then you find the derivative of the exponent. So it repeated itself times the derivative of the exponent, which is just negative 1. And all I ended up doing there was moving the negative 1 to the front, making negative x squared. And then the derivative of the first times the second. Not much there. I could factor out, both terms have x's. I could factor out an x. Both terms have e to the negative x. I could factor out that, but that's no point in that because it's not going to lead us to anything. It's just, we're done. Okay. Okay. Next one. Let me go step by step. So it's natural log of a fraction. So the natural log says top is the derivative of the stuff. The bottom is the stuff repeated. So I did the derivative. I did the quotient rule here. Low times the derivative of the high minus the high times the derivative of the low over the low squared. Okay. Distributed. Okay, so next step. That led to 2x plus 6 and then minus 2x, so the 2x's canceled out when I combine like terms. So I had 6 over x plus 3 squared, and then the bottom I haven't touched yet. So I have a fraction over a fraction. So that means I'm going to keep, change, flip. Keep, change, flip. The top times the reciprocal of the bottom. So the 2 and the 3 I could simplify. Divide them both by 2. The binomial x plus 3 and x plus 3, over here I had 2 of them. Over here I only had 1 of them. So this one went away, became a 1. This one just stayed x plus 3. So I multiplied straight across. 3 times 1 makes 3. X plus 3 times x, just x times x plus 3. You can do distributive property, but it's not necessary. Here it is. Okay. Okay, so tomorrow, like I said, all we're going to do is I'm going to give you some time to work on practice 10. Practice 10 will be due till Friday. So I'm going to be due till Friday at the end of the day. Okay, so because I haven't assigned it yet. So Friday, so tomorrow, that's what we'll do. Thursday, I haven't posted this on Google Classroom yet, but I'm going to post it right now.